tyFlow, multifracture and modifier. Learn how to understand and use it. The multifracture operator. It's an amazing operator. I mean, Tyson is brilliant. So we look at all the modes here. Voronoi, text map, radial, planar, paint, hull, edge, and bounds. And I've sorted and colorized the different rollouts so that we might try to get a handle on this operator and figure out how we can understand it and work with it the quickest. The first thing we notice is there's some standard rollouts between each mode. So you can see display is on all of them, right? And the display just gives you the power to try and display the way the fractures are being calculated or visualize the fractures. You can show the planes, you can show different modes of visualization. So if you understand the fracture display rollout for one, you understand it for all. And that's kind of how you have to think about it, right? So if we now look at fracture points, I'm going to skip input because it's rather specialized. And we also have fracture inputs, fracture points on most of the operators. Well, when we think of Voronoi, if we have a box that we're trying to fracture and we have two Voronoi points, we end up with some sort of fracture based on those points, right? So if we at the end of the day understand that in fracture points, it's going to make more or less fractures based on the number of points, so to speak. And fracture meshes, let me delete this stuff for a minute. And we now look at fracture meshes, which is in all of the modes, right? And the fracture mesh is if we had our object again here, right? Let's say that's our object, and we had a fracture mesh that kind of cut through here, right? Like this. And that fracture mesh is going to end up being whatever the resulting surface is of your fracture. So one of the settings in fracture mesh is kind of the resolution, right? The density, etc. So, and the segment size, for example. So the more detail you allow in this fracture mesh, the more detail you're going to get on your fracture surfaces. The more noise you apply to this mesh, the more bumpy your fracture surface are going to look. And there's you need to kind of have the resolution you need to be able to get the noise. Like if you have a very large segment size, you're not going to be able to apply very much noise to that, right? Because each segment size is going to be so big that a segment by itself won't distort much. So if you want a lot of kind of bumpiness and a noise in your fracture faces, you're going to need a fairly small segment size and allow a lot of segments, so to speak. And it's better covered in its own tutorial, but I'm trying to give a quickie on how to understand multifracture, right? So we can now understand that in each one of these operators, we have a way to control how that fracture surface looks, and it's done through this mesh section, right? Let me clear that. And then noise A and B. It appears in all of the modes. So noise, when we talked about our fracture mesh, noise is how is that mesh going to be distorted. Now, sometimes Tyson has noise by default, and you may not be aware that there could be a reasonably large noise set in A. I don't think he ever sets anything in B, but he does set it in A, right? You can have 35 or more by default. So you may not be initially aware that this large distortion or this large kind of, like if we look at the edge fracture by default, right, you get fairly large chunks taken out of your surface, and you go, well, geez, I just wanted small kind of tiny ones, but I'm not realizing there's a noise already set that's greatly influencing this edge fracture. So even if I turn down this setting in edge fracture, the depth, I'm not getting the result I want. It's because your noise is overriding it. So, and generally speaking, when you're looking at noise A and B, right, then generally is you kind of have a larger noise on A, and then you have a fine tuning one on B that creates smaller bumps if you so choose. So, you know, like if we kind of look at our fracture plane here, and once we apply noise, this fracture plane might start to wobble and do this kind of thing, right? You know what I mean? And then it looks something like a distorted mesh, right? And the noise is applying that distortion to our plane. And this noise is heavily dependent on what we got set in our fracture mesh, because the fracture mesh, if you kind of think about a box with no subdivision, right, with no segments, you know, you can't really bend. If you use a bend modifier or something like that, you can't really bend it too easily, or not at all, in fact, if you don't have subdivisions on your model, right, more segments. So when you want to bend a model, you end up putting more segments in. And now when you apply a bend modifier, you can really bend and distort that original model. Well, it's kind of the same thing. Fracture meshes are the meshes that cut across our model, or cut our model into pieces. And the resulting fracture surface we get is based on this mesh. So, we can adjust this mesh with its segment size and number of segments, right? And I'll have a more in-depth tutorial on that. And now we can see that really a lot of these rollouts that are common to the different modes, if you understand at least a little bit about what those common rollouts adjust, you'll be able to make better fractures in whatever mode you're in, right? And then if we look at the ones that I've crisscrossed here, right, with the white. These white asterisks, so even though in Planar it's in red mode, that's because planes appear in several of the fracture modes. But basically the white ones are settings that are more or less specific to that mode. And they're the ones where you get your main settings to adjust that particular multifracture mode, right? So you have a Voronoi text map. You can see Radial has a couple of rollouts specific to it, right? And they're where the main settings. So when you look at this kind of overview here that I've given of the different multifracture modes, you can see that if you could understand most of the common rollouts and kind of get in your head what each one of them does, and then come in here and look at just the specific settings for each of that mode and concentrate on understanding those, then it might not be difficult to kind of get an overall understanding of how to use all of these modes to create crazy good fracturing. I mean, Tyson is pretty brilliant. I think he's a savant, right? And there's a lot of power in this new multi-fracture operator, and we need some understanding to utilize that power, and I'm trying to understand all this myself. I hope this explanation, or at least this kind of overview here, gives you some idea of how to try to understand multifracture either as an operator or a modifier. Break it down into its elements and you'll probably kill it as far as understanding it. So in planar mode, or in the planes rollout, the fractures occur because of these planes. And this is going to be a quickie because I'm doing an in-depth tutorial separately, right? So right now we have one plane and we only see one plane. When we have two, we can see two, and then we can see spread and orientation. So just to give you the quickie version, the spread is the spread between the different fracture planes, right? So if I don't have any spread, I don't have much spread between them, and we didn't see any change in this instance because it was set to 0. So if I up this to 100 and up this to 100 and up this to 100 and then add some spread, the planes are going to start moving relative to each other. They're going to start spread the same as a spread operator here. So I'll put that back to 0. The orientation is the rotation against each other, and you can also adjust that in the X, Y, Z, but you play around and you increase the rotation relative to each other based on your X, Y, Z percentages. So that's the quick introduction to the planar kind of rollout adjustments. So now looking at multifracture in Voronoi mode, right? And basically most fracture in the Voronoi is done by points, right? So that would let us to believe that if we come in here and adjust the number of points, it's going to adjust the resulting number of fractured objects. Now, you can pretty well count on 2 points resulting in 2 objects being fractured. 3 would result in 3 and 4. There's an exception to that. The amount of noise you got set down here, because you can have so much noise that it causes extra fractures. So if I remove all noise and we get a flat surface, right, you can see how the noise affected the surface, and we come up here, then we're going to get exactly what I said. For every point, you're going to end up getting a resulting object, right? It's that simple, and that's a good way to think about this fracture points in Voronoi. So first, if you take away the noise so that you can understand what you're fracturing, then you can come down here and fine-tune the noise to improve it once you have the number of objects that you want. If you increase the noise too much, you might get like intersecting surfaces, in which case you're going to get more fracture objects, right? And then of course the mesh is what controls how the surface looks and is affected by the noise, right? So really, when we come into this multifracture in Voronoi mode as a quickie start tutorial, then the number of points and the amount of noise that you have on your fracture mesh, and then the density at which you set the fracture mesh to, is how your surfaces are going to look. So obviously when we have a huge segment size here in Voronoi mode, we're not going to be able to deform this very much with noise, right? The smaller the surface we have here, the better we're going to deform this surface, and then we can come down here and make our AB noise adjustments. But that's kind of the quickie mode or tutorial for how to think about multifracture in Voronoi mode. So if we now do a quickie on radial mode, and I've got an in-depth coming tutorial on all of this multifracturing I'm going to put on Udemy, right? But if we do the quickie version of the radial, then I've got this set up here to spread the parts, but you can see it's not spreading everything apart because the lines aren't reaching the edges of my box or my plate of glass. So Radial is going to create these kind of like glass breaking patterns, like being hit by a bullet or something, right? So if we kind of see, we're getting a very kind of as if a bullet impacted in the middle. We do see a plane here, but for most parts I leave the planes alone because I think you only need one kind of radial effect, right? So most of our adjustments in radial come in this radial specific section, right? And right now my lines aren't reaching the edges, so if I mess with this percentage size, I'm just going to go to around 120. Now you can see I've got a lot of lines reaching, but still not all of them, right? So I'm going to get somewhat of a decent fracture, right? Like a radial fracture, right? You can see. And so if I come back in here and increase this, I wish the rollouts would stay where they were, increase this say to 150 so I get more lines reaching out. Now I've got a lot of radial lines reaching out to the edges, and we probably get a beautiful spread pattern here, right? That's a great fracture, right, in radial mode. And then, because this is just a quickie, well, these radial lines, they're the lines that go out this way from the center, right? They go out from the center. And when we, if I do the countdown to 5, we're only going to get roughly 5 lines appearing, but we don't see that because the probability percentage, right? If I change that to 100%, we're definitely going to get 5 lines. And then if I decrease this resolution to 1, we get straight lines. So resolution on the radial lines is kind of making the noisy part available to you, right? It's like if you didn't have enough subdivisions on your mesh, you can't really warp it too much. So if we have a higher resolution here, we get a chance to deform it more based on the noise kind of deal, right? So, but you can see that because I got probability of 100%, we got 5 radial lines appearing. So these concentric lines that go round and round and round are controlled by this concentric lines section, right? And when we look at this ring percentage, one ring would be a full concentric circle or line, right? And what's the percent chance that one of these full concentric circles would appear in this fracture mesh, right? And then the segment. So if you think everywhere a radial line is coming out and you have this circle cutting through it, each segment would be the segment between 2 radial lines, and what's the percentage of that appearing. So the higher the percent, the more chance you're going to be able to see each segment, right? Now, in this current display, we're not seeing many lines, and that's because we got this resolution down here, right? So we increase this resolution, we get more chance of these concentric lines appearing, right? So we go up to a 50, which is roughly the default, right? As far as that. And then once we have more radial lines as well, something like say 20, we'll end up getting more of the original kind of breaking glass pattern that we saw, right? So all of these radial lines are, all of these concentric lines are also being controlled by this density curve. So you can adjust this density curve to have more radial lines on the inside of the mesh here, or you can have more on the outside. So if we kind of invert this curve a little bit, right, you can see now we have no concentric lines, and then we invert it, now we tend to have more away from the center. And you can play with various settings here to kind of get the look you want, right? Let me just get a control of that handle, and you can get the idea that these lines are also affected by this and noise. But that's the quickie part of this multi-fracture radial section. So multi-fracture paint mode. When we look here and come into the operator, right, we can see that there is no paint mode available in the operator. So if we want to paint our fractures, then we have to use the modifier. So that's the first important point about the paint mode. So let me set that up. So I'm back. I've created a box and I've got the Ty Multifracture on it, the modifier, and I've also put a push modifier on it so we can see what happens when we draw. So I'm going to go into the top viewport to do this because the paint version of the fracture uses a painting grid, so we enable the paint mode, and this grid is going to be where we draw our lines on it. So I like to do it in some sort of controlled fashion. It's harder to do it in a perspective kind of view. So let's say I want a fracture across here. I got paint enabled, I clicked it, and I start to draw across my line. And now I've created a fracture, and this green line is actually the fracture mesh we can see. Now we want to turn off paint mode because we've finished fracturing for this quickie. And now we can push them apart to see. There's our fracture mesh, and there's the line we drew. Now if we kind of go back into perspective mode here and look at this, and that's kind of what the default, that's how we draw fracture lines. So if we go back in here, we can click paint, draw more fractures, we can delete them, clear them, or disable them, right? And this is just a quickie to get you going. And so now, remembering that the mesh is again what creates our fracture surface, even in this modifier, we go in here and we can see the default. Let's increase the resolution by lowering this number. And you can see the fracture mesh in the middle here changed, right? It's got more resolution. Let's look at this surface, right? And let's go down to say 0.5 for this example. Now we have a reasonably high fracture mesh that we can tweak a little bit with our noise, right? So we go to fracture noise A, and maybe we do 5 is, let's do 7. Make it a bit more aggressive, right? And it's mainly changing the jiggerish line, the jiggerish, that's not a word, but anyway, you get the idea. And now, if we add a little bit more noise B, so to speak, and we don't want to overdo it here, but this is just going to give us a little bit more bumpiness on the surface, right? So now, we've painted a fracture stroke, and we've got a reasonably nice looking surface. So if we turn off edge faces for a minute, so we can just see the surface, and then we come in here in our modifier to the display and turn off all of these, and now we can see the resulting fracture surface and the fracture that we created by painting in tyFlow. I mean, isn't that awesome? It just is. So now we're going to look at multi-fracture in the text map mode, right? And I've drawn this jiggity pattern here, and we're using the modifier version because it's easier to control what happens with my map, right? And I've applied the map right now to my original box so we can just see what my fracture pattern is supposed to look like. Then we come in here to tyFlow, and we don't have a map assigned right now. That's what's supposed to do the fracture. So if I go in here to my material editor and I drop this map on here, and we'll do an instance, and now I have my map applied to my object. But you can see that the actual drawing part of it is correct, but it's way too big, right? Like, so we're not getting the fracture you want, but you can see that I did get my hand-drawn fracture line. So now if we go in here to the gizmo and we scale this and we start to get it close, we can see that we can do the fracture based on a hand-drawn line, and we could also see that we can manipulate this gizmo if we want as far as the fracture is, right? So I mean, that's the kind of basic workflow for creating a texture map fracture, alright? And if I push this a bit further apart, alright, you can see we got what we were kind of looking for, as far as the fracture, right? So if we look in Photoshop, I just created a black and white image, the black being the non-cut and the white line being the cut. And you just need to make this line wide enough. I'm only using a 3 pixel brush solid to create this jagged line for my cut, and this is 1024 by 1024. So a totally black background with a white hand-drawn line, whichever way you want, is the way that you'll get your fracture using the texture map mode, right? And if your lines don't go to the edge, and when you scale it appropriately, obviously you won't have a cut right across your surface. But that's the basic principle of creating a cut based on or fracture based on a texture map. So now if we want to visualize this a bit better, and I come back into my material editor, and instead of just applying my hand-drawn line here, I apply this yellow-blue color to my model, right? In tradition with what we've been doing so far, and then we go back into this perspective view and maximize it and zoom in a little bit here and something like that. And now we select this object and we go back in here to our modifier and we go down here to fracture meshes, and I change my material ID to 2, keeping in mind what we've had before. You can see here there's my original fracture line. I'm using the push operator to move them apart, and we have a fracture that's very much like the hand-drawn line. And then all the things that we've done before as far as noise on the mesh and the size of the size of the fracture mesh, right? Like the segment size. So if we go down to 1, we're increasing our resolution on our fracture mesh, right? And all the things that we've done before apply. We can play around with noise A and B. So if we add a bit more noise B in this instance, because it has none, we'll get more little details and bumps, but it's all based on our original hand-drawn line for fracturing. So that's fracturing by the paint mode. It's pretty cool, right? Alright, I'm going to reset that noise for now. And there you go. Alright, so now we're going to do the quickie look at the hull mode. And if we remember from other tutorials I've done, the hull is, if you took shrink wrap and what's the tightest you could shrink wrap it around an object, that would end up giving you a hull. In this case we have let me turn off tyFlow. This case we have a square kind of cubey box, so we get a fairly perfect tight shrink wrap. And on this see-through mode on my original source model, you can see where the tyFlow points are for this hull fracturing, and they're all contained within the hull of the object, right? So this is a little bit like Voronoi, and if we look at the result here, right, it's kind of based on those points, kind of like we do in Voronoi mode, right? So we turn off that for a minute and we decrease our points to just say 2. And now we can see there's 2 points here, and that's where the fracturing is going to be based. So we go into layer mode here for a minute and turn off our original object and just go into tyFlow and display it. You can see that the fractures are based on where these 2 points are, which is based on the hull. Alright, so if we go in here, alright, if we go in here and look at these parameters, and there's not many of them. The fractured faces is like before, column. We remove those faces that are those fractures that were separated from the source model, right? And then the variation is going to be, the more points we have, the more chance we're going to have some variation on where the points are, right? And the depth. So if I increase this depth those 2 points are going to move closer to each other and do more of a fracture. And let's cull the extras for now. And if we increase the number of points, we're going to get more fractures, right? So that's kind of the fracture hole explained fairly simply and quickly. And again, the resulting surfaces, I know I'm saying this in a way over and over, are based on our fracture meshes. If you don't come in here and adjust your fracture meshes, like that was the original setting 5, right? You can see very smooth, very hard cuts, like almost flat planar. And again, this is also based on noise. So if you come in here and there's a default noise set on this, it's higher than that. I've got it at 2 at the moment, but you can see that's also going to dramatically alter how your hole fracture works. So that's the quickie on fracturing in hole mode. But I mean, between all these operators, there's a lot of power here. So for this fracture bounds mode, which is supposed to be good for making wood kind of splinters, I've changed the ratio of our box to be a more long box than, say, a more cube-like flat box like we had, because that's how this thing works. Like, we're doing it by ratio, right? So right now we're fracturing here by length ratio. So because we got one that's a lot longer in a particular direction, it's fracturing across those. So when we say maximum slices, we can see we have 1 slice, 2 slice, and then for some reason when we go 3, we're not getting any more. And that's probably because of this threshold, right? So when we go down in our threshold, we now have more slices, right? So the threshold and the max slices are going to kind of work with each other or against each other to create this fracture by length ratio. And you can see here it's the longest, right? We can also have the shortest axis, right? And if we create a better kind of object here, so we go into our layer menu and we turn on the original box for a minute, and I select it, and let's go in here to our original box, and let's make it, rather than 5 by 5 here, let's make it 2. I'll do the other way, 5 and 2. Now it's more like a plank, so to speak, right? So now that we got this kind of plank-like look, right, and we're looking at the shortest axes, obviously this length ratio is not going to be good. Let's do something like 0.05. And now we can see we have this kind of long way splintering. Well, how do we end up controlling that more to give us a long kind of fractured look like splinters, right? I mean, this is not bad, but at some point here we probably have to come in here and our fracture planes and tweak in here. So I've zeroed everything here in this planes, and we got 1 plane count, and we're looking at our model. And now what we really want is kind of this long splinter look. How do we get there? So I'm going to switch this orientation to default. Alright, and now we get these long flat cuts, like it's been sliced on the thin part of the wood, right? So how do we change that to be more like a splintering of the wood? And, you know, so divergence we talked about earlier was like the rotation of the planes, right? So we do it 100% in the Y direction, and we say put 50 here as a number just to start. Now we can see we're getting not a bad kind of looking splintering of the wood, right? We've created a splinter-like effect, long kind of splinters, we can also play with this normal scale. And so now we're going to get more longer broken off pieces, right? So, I mean, this is just a quickie, but you can get the idea here that you can kind of create long kind of splintered pieces of wood. Alright, let's do something like 20 on the X scale here. And now you can see that we've just created these long kind of broken off bits. Maybe we do 15. Alright, then we've only got one plane. We can increase the plane count. So now we really kind of get this kind of splintered wood effect. Alright, so it's all a matter of kind of playing a little bit and trying to understand these parameters. I know this is a quickie tutorial and I'm doing a full-on one, but it's going to take a little bit. But I hope this kind of gets you going. There's just a lot of stuff that can be done with this multi-fracture operator. Have a good one, everybody. In-depth tutorial or training coming to Udemy soon. See ya.